All right, last unit, or last section in this unit right here is 16.4. Now, we're still doing proofs. You guys will be so excited to see that. We're still doing proofs, but this time we're going to prove that parts are congruent. So instead of proving that triangles are congruent, we're going to prove that sides are congruent or angles are congruent. So our big, it's not really a theorem, it's just a definition right here, is going to be called CP/CTC. Now this stands for, the first C right here stands for corresponding. So corresponding, I ran out there. Corresponding. And then the P stands for parts of congruent triangles are congruent. So when I was your age in my geometry class, we used to just say, we just used to call this congruent triangles. But they're going to say corresponding parts of congruent triangles are congruent. So CP/CTC, that is one of your reasons. Okay, that's a reason right there. So when you're asked to prove that sides, let's not do sides. Sorry, how do I back up there? Parts are congruent. We're going to use it as parts because it could be sides or it could be angles. So when you're asked to prove that parts are congruent, you're going to use CP/CTC. Now, in order to use CP/CTC, this is huge and important. You first you have to prove that the triangles are congruent. Okay, so you still got to prove the triangles are congruent just like you did in 16.3. And then you could say, so, therefore, since the triangles are congruent, that means all the corresponding parts, that all of the angles match up, all of the sides match up. All right, so let's look at this first question right here on your homework. We were given, notice right here, we're given that AB is congruent to AD. So I'm going to go ahead and give that as one of my statements. AB is congruent to AD. That was just given to us. And we were also told that BC, the segment BC, is congruent to the segment DC. So BC right there is congruent to DC. Those are also congruent. Now, what they're trying to have us prove right here, notice we have to prove that the angle BCA, they want us to prove that this angle is congruent to angle DCA. So those, we don't know that those are congruent yet. That's what we're trying to prove. So what we're going to do right here, because we have nothing, our givens here tell us nothing about those angles. They're not vertical angles. We cannot prove those by themselves. But if we could prove that the triangles are congruent, if we can prove that this ABC is congruent to ADC, then we can say, therefore, all their parts are congruent. And that means that angle C with, or angle ACB, sorry, they call it BCA, is going to line up with angle DCA right there. So we're now trying to prove that triangles are congruent. This is our first thing right here. So let's go ahead and we know one more thing. Notice that lovely reflexive property. There's a line that both of those triangles share. So I'm going to go ahead and say that AC, the segment AC, is congruent to itself, AC. And that is by the reflexive property. All right, and I forgot to write the given down right there. So those first two things were given, and then it says that we have, oops, I didn't want to lose my picture. So we've got three sides right there is what I'm trying to say. Now, this is the tricky part. You do have to write the triangle in the right order. When we're trying to prove that triangles are congruent, I'm going to say that triangle. Now, I'm going to go ahead and just call this first triangle ABC. Alphabetical order, nice and easy to write. Triangle ABC is congruent to. Then what I do is I look, you've got to line up, these triangles have to be in the same order. So notice in this top triangle right here, A, what I called A, was in between side with 1 tick and the side with 3 ticks. So when I look at the bottom triangle right here, I'm going to look between 1 tick and 3 ticks. That's also A. Okay, then you look at this B right here. B was in between 1 and 2. So between 1 and 2 down here is my D, and that leaves C as my last letter. So we know that those two triangles are congruent by our side, side, side congruence theorem. Okay, side, side, side says those two triangles are congruent. Now, after we know that those triangles are congruent, then we can go ahead and say, well, that means that these parts are congruent. This C right here, notice it's between the 2 ticks and the 3 ticks. This, I shouldn't call it C. We should call it BCA. BCA right here. That is going to line up with this angle between the 2 and 3 ticks over here, which they're going to call DCA. So angle DCA. So those two are congruent because we know that corresponding parts of congruent triangles are congruent. So that's how you're going to use CP/CTC to prove parts. You still, first again, guys, you have to prove that the triangles are congruent. So we said the triangles are congruent, then we can use CP/CTC to line up all of the different parts.